4,000 years ago, while humans were building pyramids in Egypt, the last woolly mammoths were dying on a remote Arctic island, likely only a few hundred individuals remaining. Some years, entire herds may have been made up of relatives, so inbred that genetic analysis reveals they were functionally a single extended family. They weren't killed by predators. They weren't starving. They were collapsing from within. Every generation weaker, sicker, less able to reproduce, until finally there was nothing left but bones scattered across frozen ground. They'd survived 300,000 years of ice ages, droughts, and climate swings that killed nearly every other giant. But warming climate and human expansion had already pushed them to isolated islands where something else finished the collapse. Because the mammoths didn't just disappear, we built our survival on theirs. We hunted them. We sheltered in their bones. We carved their images into cave walls while they were still alive. And when they were gone, we learned to live without them. But before they disappeared, something extraordinary was found in the ice. In 2013, a reindeer herder walking across the Siberian tundra near the Laptev Sea noticed something protruding from a thawing riverbank. Not rock, not driftwood, but something curved and ivory-colored, stained dark by thousands of years underground. He called researchers from the Siberian Academy of Sciences. When they arrived and began carefully excavating the site, they realized what they'd found: a nearly complete woolly mammoth carcass, so well preserved by permafrost that when they lifted it from the frozen ground, liquid blood flowed from the specimen. Liquid blood, from an animal that died 28,000 years ago. They named her Yuka, and she changed everything scientists thought they knew about mammoth biology. Because this wasn't just bones and tusks, this was skin, muscle, organs, hair, a window into how the most successful Ice Age megafauna actually lived. And when researchers examined that tissue, they found something that explained why woolly mammoths dominated the northern hemisphere, while other giants went extinct. They were engineered for cold in ways no living animal has ever matched. The hair wasn't just thick, it was a two-layer system. Long guard hairs up to 3 feet long that shed water and snow, and dense underfur that trapped heat in a layer of insulation up to 4 inches thick. The ears were tiny, only 6 inches long, compared to an African elephant's 6-foot ears. Less surface area meant less heat loss. But the most remarkable adaptation was invisible from the outside. Woolly mammoth blood contained a variant of hemoglobin that released oxygen efficiently, even in freezing temperatures, something that would cause frostbite and tissue damage in modern elephants. Being perfectly adapted to minus 50 degrees works well, until the planet stops being minus 50 degrees. Male woolly mammoths could reach 12 feet at the shoulder and weigh up to 6 tons, roughly the size of an African elephant, but with a completely different body plan. Shorter legs to reduce heat loss, a massive hump of fat on the back for energy storage during brutal winters, and tusks that curved dramatically inward, sometimes exceeding 15 feet in length. Woolly mammoths weren't solitary. They lived in herds, led by matriarchs, the oldest females who carried knowledge of migration routes, water sources, and seasonal grazing grounds across decades of experience. And humans learned to exploit that predictability. In 2020, archaeologists excavated a site near Mexico City that changed our understanding of human-mammoth interaction. Not a kill site with scattered bones, but something far more sophisticated: a pair of circular pits, 50 feet across and 6 feet deep, deliberately dug into the earth 15,000 years ago. The pits were mammoth traps. Lined with sharpened stakes and disguised with vegetation, these traps were positioned along known mammoth migration routes. Hunters would drive entire herds toward the concealed pits, using fire and coordinated group tactics. The mammoths, following their matriarch along traditional paths, wouldn't see the danger until it was too late. The lead animals would fall. The rest of the herd would scatter, And humans would have meat, hide, ivory, and bone for months, enough to sustain entire communities through brutal winters. Over 800 individual mammoth bones were found at this single site, representing at least 14 mammoths killed using the same trap system over multiple hunting seasons. This wasn't opportunistic scavenging. This was industrial-scale hunting. Humans looked at a 6-ton animal and thought, let's dig a hole. And it worked, repeatedly. And it was happening across the entire northern hemisphere, from Siberia to Alaska, from Europe to North America, everywhere humans and mammoths coexisted. Humans were learning, adapting, improving their kill rates. Which raises a question. If mammoths survived 300,000 years of climate fluctuation, what made the last 15,000 years different? The fossil record tells a detailed story, and the story is one of accelerating decline. Mammoth remains are found across the entire Holarctic realm, the vast region encompassing northern Europe, Asia, and North America, from Britain to Beringia, from southern Spain to the Arctic Ocean. During the last glacial maximum, 20,000 years ago, mammoths were thriving. Abundant populations, healthy bone density, successful reproduction across their entire range. But in deposits dating to 15,000 to 12,000 years ago, something changes. Mammoth bones from this period show increased pathologies, evidence of malnutrition, stress fractures that healed improperly, juvenile remains suggesting high calf mortality. Tusks from late-period mammoths show irregular growth patterns, annual rings that indicate periods of starvation, followed by brief recovery, then starvation again. They were struggling, and the fossil record shows it was getting worse fast. And at the same site in Siberia where Yucca was found, researchers discovered something else. Human artifacts, stone tools, carved ivory, the remains of a dwelling constructed partially from mammoth bones, same location, same time period, different species. Humans weren't just hunting mammoths, they were living in structures built from mammoth skeletons, wearing mammoth hide, carving mammoth ivory into tools and art. Mammoths weren't just prey, they were infrastructure. Humans didn't just hunt woolly mammoths, they studied them, tracked them, and depicted them with anatomical precision that could only come from prolonged, direct observation. Cave paintings from Rouffignac Cave in France, created approximately 13,000 years ago, show woolly mammoths in remarkable detail. The distinctive shoulder hump, the curved tusks, the shaggy coat, even behavioral details like trunk position and social grouping. Over 150 mammoth images in a single cave system. At Chauvet Cave, also in France, mammoth depictions include details invisible from a distance, the position of the small ear, the shape of the domed skull, the texture of the fur. These weren't symbolic representations. These were field sketches, reconnaissance of a resource humans could not afford to lose. Which means humans were close enough, frequently enough, to observe mammoth behavior in detail. And the mammoths, like modern elephants encountering persistent human presence, likely learned to recognize and avoid human hunting parties. But unlike modern elephants, woolly mammoths couldn't migrate away from human pressure, because humans were spreading across every landscape mammoths inhabited, following the same migration routes, targeting the same seasonal grazing grounds. Nowhere was safe. Which raises another question. Did mammoths fight back? There's evidence they did. Human remains from mammoth hunting sites occasionally show catastrophic injuries, crushed bones, puncture wounds consistent with tusk strikes, evidence of trampling. Mammoth hunting was extraordinarily dangerous, and not every hunt succeeded. But humans were getting better at killing them. Around 12,000 years ago, the climate began shifting rapidly. The Pleistocene was ending, the last ice age giving way to the warmer, wetter conditions of the Holocene. Glaciers retreated. Sea levels rose. The vast, continuous grasslands of the Mammoth Steppe, that cold, dry, nutrient-rich ecosystems stretching from Spain to Alaska began fragmenting into isolated patches, separated by expanding forests and wetlands. Woolly mammoths were adapted for open grassland. Their digestive systems evolved to process tough, low-nutrient grasses in massive quantities, up to 400 pounds of vegetation per day. As forests expanded, replacing grassland with trees, mammoths lost their primary food source. Missing one meal wasn't inconvenient. It was a crisis. But climate change alone doesn't explain the extinction pattern, because mammoths had survived previous warming periods, previous glacial cycles, over 300,000 years of climate fluctuation. This time was different because humans were different. By 12,000 years ago, human populations were expanding rapidly, spreading across every continent except Antarctica, developing increasingly sophisticated hunting technology, atlatls, that could launch spears with lethal force from safe distances, coordinated group tactics that could bring down animals 10 times their size, knowledge-sharing networks that spread successful hunting strategies across entire continents. And they were targeting mammoths, specifically, not just for meat, but for hide, ivory, bone, fat. A single mammoth kill could sustain a human group for weeks. The incentive to hunt mammoths was enormous. Climate warming removed their habitat, human hunting removed their individuals, squeezed from both directions with no time to adapt. By 10,000 years ago, mammoth fossils become scarce across most of their former range. The latest confirmed mainland specimens date to approximately 10,000 years ago in North America, 9,000 years ago in mainland Siberia. After that, only isolated island populations remained. Wrangel Island, a remote landmass in the Arctic Ocean north of Siberia, preserved the last woolly mammoth population, a small group isolated from both human hunters and mainland climate change when rising sea levels cut the island off approximately 10,000 years ago. For a while, isolation meant survival. These island mammoths survived another 6,000 years, adapting to their restricted environment by evolving smaller body sizes, adults reaching only 6 feet at the shoulder, roughly half the size of their mainland ancestors, a common evolutionary response to island isolation and limited resources. But small population size creates problems that size reduction cannot solve. Inbreeding, reduced genetic diversity, accumulation of harmful mutations. Researchers analyzing DNA from Wrangel Island mammoths found evidence of severe genetic degradation, mutations affecting essential genes, loss of functional genetic variants, signs of inbreeding depression that would have caused visible deformities, reduced fertility, weakened immune systems. The population was so small, every mammoth was related, and there was no one new to meet. By 4,000 years ago, while humans were building the pyramids, while Bronze Age civilizations were flourishing across the Mediterranean, while cities rose and empires formed, the last woolly mammoths on Wrangel Island went extinct. Not from hunting, not from predation, not from dramatic environmental collapse, just slow genetic decline in an isolated population with nowhere left to go. At that point, extinction becomes math. They didn't die suddenly. The herd shrank, the bloodlines narrowed, the mutations accumulated, until one year, there were no more births. And then, there were no more mammoths. They didn't vanish, they faded. Woolly mammoths weren't killed by inability to adapt. They were the most adaptable megafauna of the Pleistocene, surviving 300,000 years of dramatic climate fluctuation, spreading across 3 continents, thriving in conditions that killed nearly every other large herbivore. But they evolved for a world of slow change. Climate shifts measured in tens of thousands of years, not thousands. Threats they could migrate away from, not threats that followed them everywhere. Competition they could outlast, not competition that improved its tactics every generation. Humans changed that equation. The danger wasn't human hunting alone, it was the speed. Climate warming and human expansion accelerated the timeline, compressing change from tens of thousands of years to mere thousands. faster than any large mammal could adapt. By the time humans reached most regions, only isolated island populations remained, and even those populations eventually collapsed from genetic isolation. Today, elephant populations, the closest living relatives of woolly mammoths, number fewer than 500,000 individuals across Africa and Asia, down from millions a century ago, still declining from habitat loss and human pressure. But 15,000 years ago, mammoths alone numbered in the millions, inhabiting more territory than all modern elephants combined, dominating the northern hemisphere across 3 continents. We have their remains in permafrost, some so well preserved that cells remain intact, DNA recoverable, soft tissue analyzable. We have their tusks in museum collections, their bones in archaeological sites, their images on cave walls. And we have evidence of what we did: the trap sites, the kill floors, the dwelling structures built from their skeletons, proof that human survival depended on mammoth extinction. The woolly mammoth didn't disappear because it was weak. The most cold-adapted animal ever to exist died when the world got warmer and changed faster than evolution could respond. The world changed, and they couldn't change fast enough.